Hello, hi everyone. Welcome to the Student Brand. So this is your Sivas here. Hello, hi everyone. Welcome to Student Brand. This is your Sivas here. Today we are going to discuss about so light reflection diffraction completed electricity. So we are talking about electricity. Hi Tanishka. Hi. Yeah, hi. So setup problem. So costume. So actually I thought to take before itself due to some concerns. Actually, I want to show you. Hi, sir. How are you? Hi, Sivani. I want to show actually nearly almost nice costume. Almost I worked nearly 5 years. Not only 5 years, nearly 9 years I worked. Okay. So I did so many experiments. I want to show you some of the experiments because uh, hi bro. Because I experimented, so I did so many experiments in physics. So like these all experiments went unnoticed. So I don't know what happened. But today I want to discuss though about those experiments, activities, and see over a 9 years hard work, nearly 9 years hard work. Mine. Okay, even when I'm teaching also, I went with the costume. I went with the costume. So I did so many experiments with so you can see my videos, YouTube videos. There are so many plenty of experiments like songs. Today, along with that, so I want to show you. Today, I will discuss about light electricity problem. Sorry, electricity question and answers, and along with that, a few problems I'll discuss. And end of the class, I will show you my hard work over 9 years hard work. So, like many experiments, many activities, many costumes. So while teaching physics, so when I'm teaching that time I utilized, but I didn't get a chance to talk. I didn't get chance to no teach with the costume because somewhere. Okay, let me continue with the normal teaching. Then so we'll go with that experiment more. Like that I thought. So but one day, so our inner voice won't listen us. Inner voice, whatever there it is there in our inside. So inner voice won't leave. So it won't leave. So definitely, so you have to come up with that. You have to come like that. Hi. So like that. So inside my inner voice telling continuously. So somewhere you are missing somewhere like that. So we need to go with the experiment mode again like that. So I started actually these activities, these experiments. So from many years onwards, I'm doing. Okay, even when I'm teaching. So when I'm teaching physically, okay. So in the in the classroom itself, in the classroom also I went with like that only. I went with like that. So like over this many years I did so many experiments. So with the classes I didn't teach. So with the classes I didn't teach through online I didn't teach. I didn't go with that activities. But in the classroom I went with that. In the classroom I went to. So children, so students, they enjoyed a lot. They enjoyed a lot with the costume. So now I want to show few moments that. And so I will sing one song. I will sing with the drum also. So like that. So yeah, definitely. So with the songs, I thought the classes. With the songs, I thought the classes. So nearly 10 songs, nearly 10 songs, nearly 10 songs, 10 songs, 10 songs I created. So on the physics, so students, they enjoyed a lot, so I want to go with the same process, same method of teaching. So these are the teaching aids of mine. So we'll see. So stay tuned. Keep watching, definitely. You'll be having a great experience with the class. So with the music, with the drums, with the background, definitely I'll teach the topic. So physics songs. So physics songs in the sense concept. Concept only I'll sing. Concept. So you can learn. Easy in easy way. You can learn in a better way. Okay. So sample like myopia. Myopia, myopia, myopia. Near distance we can see a far distance we can see a myopia, myopia, myopia. For that correction we are using. Bro, what bro? For that correction we are using concave concave lens, concave lens, concave lens, concave lens. So like that. So it happens like that. So I did in the class itself. So those days, so it's very happy. Now again I want to go with that same methods and no teaching aids. So you can check my videos, you can see my videos, nearly 3000 videos. Okay, 3000 videos. There are many experiments with the teaching. So if you want, you can go to the channel, check in the channel, so watch the videos. So definitely, so you'll get the concept. See, whatever I'm doing with the concept, the main motto, the center point is, the center of attraction is concept. So physics, how best we can go with that, how best this concept should reach to the students, how we can go, how can we go with the different modes, different methods. Like that I went with all these things. So we'll see, so what happens in future. So as I already said now, so here, this is a concave lens, you can see this is a concave lens, so like so many activities I said, right? So this is a convex lens, so here you can see this is a convex lens, like that. It's like a costume manner, like that, so you can see, observe. Yes, so convex lens, completely it's a convex lens. So convex lens, right? Convex lens. So in easy way, so students, by seeing that, immediately they will recognize, they will identify. Okay, sir so said that convex lens, and sir shown that concave lens. No, they will end, they will, by seeing that one, immediately they will get it. So that's why this many experiments, on physics. There are many experiments I did. Okay, still so it is counting, so it's continuous. So until, okay, so until how many days we can go with that, definitely I'll continue. There are many experiments. Okay, so stay tuned until the end, you be in the class. Definitely you'll get the concepts with different, no, we can say different experience. So if you like this video, please do like, share and subscribe, and share to your friends, inform to your friends. We'll go with the concepts. Okay, anyway, so the main motto, we should not deviate from the main motto. So I'm considering here, like that. So few questions, I'm going to ask few questions related to electric current, electricity, few questions. Hey, hi, sorry for that, I'm continuously talking, right? That's the reason. Twinkle, hi. Shivani, anyway, Shweta, okay. So, Fairy. Someone name is Fairy. Hi. And anyway, as usual, Daniel, hi. Uh, Shivani, hi. Tanishka, hi. Okay, done. So, if you like this video, if you, okay, so you can do comment or, hey, hi. So actually, I didn't make the songs. Songs means with the teaching. For teaching itself, I made all the songs for teaching purpose. Teaching purpose only, not with normal song. Twinkle, hi. So I said. So what is your name? What is your name? What is your name? I'll ask few questions. I'll ask few questions if you have, if you know that, if you know that. Okay, so you can. So every day, anyway, 10 o'clock, every day talk will be there. Sir, please sing one song. Yesterday I saw two of your full live streams. Oh, thank you so much. So yesterday, see, every day, definitely, every day it will be there. Every day it will be there. So you can check once. You can check once. Go through the remaining streams also, and videos also you can see in a playlist, so you can get it in playlist. If you go to playlist, so there are many videos are there related to light reflection refraction. You can check it once. So today we can see few related to problems. Actually problems we have to do. So problems we have to do. We'll go with the circuit problems. Shall we do circuit problems? How many are interested? Circuit problems, let me know. Circuit problems, will do it. Otherwise, so we'll go to the normal question and answers. Question and answers, like important questions. So whatever we learnt till now, whatever we learnt related to electricity chapter, there are many questions are there. So we are, whatever we are learning, those are, sir, your clothes are amazing. How long it took to make? Yeah, of course. Actually, when I'm teaching until 2 o'clock, 3 o'clock, until 2 o'clock, 3 o'clock, I will wake up. So I'll wake up until 3 night, until 2, 3. I'll wake up and do the costumes and will go to the class. So like that, like so many days. Even here also, after that also, until 1. Okay, so until I will finish that day costume, so I won't go to the sleep. So like that, I did so much hard work, so much hard work. But few after that, I took some gap. Okay, so for the costumes and normal teaching. Then now still now, so I'm sharpening my experiment mode. So we'll see. Okay, fine. So definitely I'll answer your questions. So that is the reason talk with Shiva sir. Like if any words are like that, if any things, because so main motto I said no, main motto subject. With the subject, we'll go with the different. We'll go with the remaining things. So coming to the concept. SI unit. Name the SI unit of electric charge. What is the SI unit of electric charge? Charge SI unit. What is the SI unit of charge? Coulomb. SI unit of charge is coulomb. So SI unit of charge is charge. Charge SI unit. Charge. So we can see. What is the charge SI unit? Charge. Charge SI unit. SI unit of charge. SI unit of charge. SI unit of charge is coulomb. SI unit of charge is coulomb. Okay, so like this, simple. You may think those are very simple, but but you can see MCQs, whatever MCQs, the background. Okay, me only. So I did so many experiments like that. So you can check that one. So short videos also there. So short videos also, I made so many costumes. So you can check once. And coming to the next one, define electric current and SI unit of electric current. What is electric current? So define electric current, they asked. Define electric current is nothing but, so the rate of flow of charge, I equal to the rate of flow of charge, or a flow of charge through unit cross section area per second. Flow of charge through unit cross section area per second. Huh? Hey, multiplayer, hi. And free edit some name, so I don't know. What is your name? Just check once. Okay, so electric current. Electric current is nothing but the rate of flow of charge. Rate of flow of charge. SI unit of electric current is ampere. Rate of flow of charge. Rate of flow of charge. The flow of charge through unit cross section area per second. Flow of charge. Flow of charge through unit cross section area per second is called electric current. SI unit of electric current is ampere. And state the relationship between 1 ampere and 1 coulomb. State the relationship between 1 ampere and 1 coulomb. State the relationship between 1 ampere and 1 coulomb. So 1 ampere and 1 coulomb. 1 ampere and 1 coulomb. So that is nothing but we can say, so 1 ampere. I equal to Q by T. So I equal to Q by T. They ask, state the relationship between 1 ampere and 1 coulomb. So 1 ampere equal to 1 coulomb of charge flowing through 1 second. 1 second. If it is relation between 1 volt equal to 1 joule by 1 coulomb. So this is the relation between work and potential difference and work. Potential difference. So work done to bring unit positive charge from one point to another point. Work done to bring unit positive charge from one point to another point. That is nothing but a potential difference. So normally if you take 1 ampere and 1 coulomb, 1 ampere equal to 1 coulomb per 1 second. So what is an ammeter? How it is connected in a circuit? What is an ammeter? Ammeter is a device. So normally, see, I already said 1 mark MCQ's point of view, very, very important. Question and answers also very, very important. MCQ's part also very important. Okay. So what is an ammeter? How it is connected in a circuit? Ammeter is a device. Ammeter is a device which is used to measure the electric current. Ammeter is a device which is used to measure the electric current. How you are connecting ammeter? Ammeter will be connected in series combination. Ammeter is connected in series combination. Next one, one more very, very important. What is what is the SI unit of potential difference? What is the SI unit of potential difference? What is the SI unit of potential difference? Can anyone say what is the SI unit of potential difference? Volt. SI unit of potential difference is volt. SI unit of potential difference is volt. SI unit. Shivani, actually, I only made those songs. So I read yes, I only made those songs, lyrics and everything I only did. Okay, come to the point. So SI unit of what is the SI unit of potential difference? Volt. SI unit of potential difference is volt. Define SI unit of electrical potential. SI unit of electrical potential. 1 volt. So already equal to 1 volt equal to 1 joule of work is done to bring 1 coulomb of charge. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge. 1 coulomb of charge. So what is meant by resistance of a conductor? What is meant by resistance of a conductor? Resistance of a conductor is nothing but the phenomena of opposing the electric current. The phenomena of opposing the electric current. So the phenomena of opposing the electric current is known as resistance. So that is the SI unit of resistance, ohm. And next one, name and define the SI unit of resistance. So we can see this type of questions. Whatever I am discussing, make sure that you are learning. And next one. Here, an electric source can supply charge. Charge is given and current device, so milliampere is given. Find the time in which the electric source will be discharged completely. So here you can observe charge is given, current is given. Find the time. So time they're asking. So Sivaram, hi. So will you find out this one? So charge is given. Charge is 500 coulomb. Charge is 500 coulomb. So check once. Charge is 500 coulomb. Charge is nothing but, so charge I am taking I equal to Q by T, right? I equal to Q by T. So we can see the question is charge is given, that is nothing but Q is given 500 coulomb. And so ampere current is given 25 milliampere. 25 into 10 power minus 3 ampere. So milli means 10 power minus 3. We have to take 10 power minus 3. So we can see I equal to Q by T. So 500 500 equal to 25 into 10 power minus 3 into t into t. So if it is goes up, if it is, you can cross multiply. If you cross multiplying, so then we'll get 25 into 10 power minus 3 by 500. So we can see how much you'll get it. How much you'll get it? Check once. An electric source. So coulomb they given. So milliampere 25 into 10 power minus 3 ampere. Current is given. So I equal to Q by T. Time they ask. So I will go down. Okay, sorry. Here charge, right? Charge 500. Charge is 500. Current is 25. 25 into 10 power minus 3 ampere. So charge is 500 by T. Now you see. So T equal to 500 by 25 into 10 power minus 3. So T equal to 500 into 10 power minus plus 3 by 25. So that many seconds you can check, calculate. So what is microampere? So it is millima. So milliampere. So micro means this is the symbol micro. Micro means this is, so m is milli. Milli means 10 power minus 3. 10 power minus 3. 10 power minus 3. Okay, try to solve. Try to solve like that. You can check once. So here charge is 500 and current 25 milliampere. So 10 into 10 power minus 3. So milliampere. M is milliampere. Milliampere. Milliampere means 10 power minus 3 ampere. 10 power minus 3 ampere. So here 500 and the current is 25 into 10 power minus 3. So time you can cross multiply 500 by 25 into 10 power minus 3. If it is goes up 10 power 3, so 500 into 10 power 3 and 25. So you can cancel it and do the value. Okay, done. So next one. Next one you can see, define resistivity of a material, give its SI unit. Very, very important. Define resistivity of a material. What is the resistivity of a material? Resistivity of a material. Can anybody say resistivity of a material? Resistivity. So I already given the definition of resistivity, right? Resistivity is nothing but, so formula. At least you can see the formula. Formula. So I'm considering now. So resistivity is equal to, so here you can see R equal to into L by A, rho equal to RA by L, rho equal to RA by L. So normally R equal to rho into L by A, R equal to rho into L by A. Specific resistance only. Resistivity is nothing but specific resistance. Rho equal to RA by L. Resistivity is equal to resistance of a conductor per unit length and unit cross section area. Resistivity is equal to resistance of a conductor per unit length and unit cross section area. That is nothing but resistance. So SI unit of resistivity is, so ohm meter square by meter. Meter square by meter. So meter get cancelled, then we will get ohm meter. So rho equal to ohm meter. 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 So SI unit very, very important for 2 marks. Very, very important for 2 marks. For 2 marks, very, very important. Make sure that so you are learning this one for 2 marks. Yes, compulsory. This question will come for 2 marks. Compulsory. This question will come for 2 marks. So prepare. Okay. So learn it. Next one. State Ohm's law and write the condition in which the law is obeyed. So this question given in the exam, and the previous question also they given in the board exam. So problem whatever I explained, that question also they given. This question also will come in so already this question they given in exam. What is that? State Ohm's law and write the condition in which this law is obeyed. So what is Ohm's law? What is Ohm's law? Ohm's law, can you tell me? So Ohm's law is nothing but Ohm's law is nothing but at a constant temperature, the potential difference is directly proportional to current flowing through it. So Ohm's law is nothing but the potential difference. Okay, the potential difference across a metallic conductor is directly proportional to current flowing through it at a constant temperature, at a constant temperature, at a constant temperature, at a constant temperature, at a constant temperature. The potential difference across a So is it visible and audible to everyone? So let me know if any concern is there. Is it clear? Okay, so we'll go to the next one. State Ohm's law and write a condition in which this law is obeyed. So Ohm's law is nothing but if you are considering the potential difference across a metallic conductor is directly proportional to current flowing through it at a constant temperature. The potential difference across a metallic conductor is directly proportional to current flowing through it. That is nothing but Ohm's law. List the factors on which resistance of a conductor depends. Write the formula showing relation of resistance with these factors. So I already said resistance is directly proportional to length. 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 Directly proportional to length is resistance is inversely proportional to area. So R is directly proportional to L by A. R equal to rho into L by A. So rho into L by A. Rho into L by A. So once again, so resistance is directly proportional to length. Resistance is inversely proportional to area. So resistance is directly proportional to L by A and R equal to rho into L by A. R equal to rho into L by A. R equal to rho into L by A. So this is about list the factors on which resistance of a conductor depends. So write the formula showing relation of resistance with this factor. So it depends on resistance depends on length. Resistance depends on area. Resistance depends on length. Resistance depends on area. Resistance depends on area. Okay, so these are the factors. And coming to the next one. Okay. So here, one question given. Write the factors on which resistivity of Y depends. Resistivity of Y depends. Can you tell me on what factor resistivity of Y depends? Resistivity. So here, resistivity depends. Already given. So if you watch my videos, you can get it. So you can check the videos, whatever I explain. Whatever I explain. So resistivity depends on. Resistivity depends on. Resistivity. Resistivity depends on. So on what factors resistivity depends on? Can you tell me? Anybody can you tell me on what factor resistivity depends? Resistivity depends. Resistivity depends. Anybody? Sir, why add? Huh? It's not add. So it is my costume. What is your doubt? So you joined in previous class also, right? In previous class also, your name you said something. I'm Dhanush. No, some name. Okay. What's your name? Yeah, remember, I remember. That's why that day I called your name, Neymar. So he's the friend of, yeah. Himanshu, yes. So you joined, right? That day you joined, and I said your name, Neymar. So you mentioned it's not my name, like that. We discussed also, yes. I remembered you. Okay, so fine. Yeah, in the previous class, okay. I said one question. So before that, I'll tell. Okay, in the previous class, I said one question. Okay, related to this one, definitely one 3 marks question will come. Related to this one 3 marks question will come, I said. So that is, you can see the charge possessed by an electron is 1.6 into 10 power minus 19 coulomb. The charge possessed. Okay, so that is 1.6 into 10 power minus 19 coulomb. Find the electrons, find the number of electrons that will flow per second to constitute a current of 1 ampere. I already said this question will come for 3 marks. Definitely this question will come. You have to practice. So in my previous classes, you can observe. So in that I explained. So now I will explain once again. Check once here. Here once again, resistivity depends on temperature and material of the medium. So resistivity depends on temperature and the material of the medium. Resistivity depends on temperature and material of the medium. So charge, so if you are taking one electron, so one electron, if you are taking 1.6 into 10 power minus 19 coulomb. So 10 power 19 coulomb. Okay. So time equal to 1 second. Time equal to 1 second. And current equal to 1 ampere. Current equal to 1 ampere. Already said this question. This question will come. So this is very, very important. So here you see the charge possessed by an electron is 1.6 into 10 power minus 19 coulomb. Find the number of electrons that will flow per second to constitute a current of 1 ampere. So very, very important question. Very, very important question. So very, very important question. Very, very important question. Very, very important question. So NE by T. I already said. So this value you have to remember. Time also given, ampere also given. We have to form. This is 1 mark question. Definitely will get for 1 mark question. Very, very important. 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 Highly important. Highly important. Definitely this question will come. Definitely this question will come. Definitely this question will come. Very, 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 very. Very important. Okay, so this question in the exam, definitely for MCQs. So in MCQs, definitely this question will come. So make sure that you are practicing. Make sure that you are practicing. Make sure that you are practicing this question. Make sure that you are practicing this question. 100% this type of question they will ask in exam. They will ask in exam. So one electron, how much charge is present? High. So I hope someone name. So what is your name? Something name. So here 1.6 into 10 power minus 19 coulomb. So T equal to 1 second. So S said it's what is your name? Can you tell me? Here you can see no, 1 ampere equal to T equal to 1 second, I equal to 1 ampere, I equal to NE by T. So NE by T. So like that we can say. Now you can go with that. Now we can go with that. So you can substitute the values. So 1 equal to so n into 1.6 into 10 power minus 19 by 1. So minus 19 by 1. So now you can see, if you want to find out electrons, n equal to 1 by 1.6 into 10 power minus 19. So if you solve this one, that will get n equal to, so 1 by 1.6 into 10 power 19. 10 power 19, that is nothing but 0.625 into 10 power 19. So that will get 6.25 into 10 power 18 electrons. So 18 electrons. So n value 18 electrons. So that is the answer. That is the answer. This question will come for exam. So sure, practice this one. So very, very important for 3 marks. So for this question will come for 3 marks. This question will come for 3 marks. 3 marks. Very, very important question. Very, very important question. So for exam point of view, so make sure that you are practicing this question. Make sure that you are practicing this question. Clear? Now we can go with that. We can go with that one more. So we can go with that one more. So distinction between terms electrical resistance and resistivity. Electrical resistance and resistivity, definitely this question. This question is highly important, very, very important. Resistance. Resistance is nothing but the phenomena of opposing the electric current. SI unit of resistance is ohm. SI unit of resistance is ohm. SI unit of resistance is ohm. SI unit of resistance is ohm, and it depends on length, it depends on mass, and it depends on temperature, and depends on temperature, and depends on we can say material of the conductor. Whereas resistivity, so resistivity is equal to resistance of the conductor per unit length and unit cross section area. So resistivity depends on temperature, resistivity depends on temperature, resistivity depends on temperature, resistivity depends on temperature, and resistivity depends on material of the conductor. Okay, so make sure that you are practicing this question. And coming to the next one. Yes, so this question is very, very important. So one more question for 3 marks. So resistivity is given, cross section area is given, resistance is given. So we need to find out the length. We need to find out the length. So how to find out the length? We will see now. So as already said, so these type of questions will come for exam. So definitely, so make sure that from electricity chapter, so we may not expect okay, so different questions. So they will ask from basics. So if you are perfect in basic, definitely these questions will come. Here you can see. So question, resistivity is given. So 1.6 into 10 power minus 18, 10 power 18, 10 power 8. So 1.6 into 10 power 8, 1.6 into 10 power 8, and area of the cross section is given. So 20 into 10 power minus 4 centimeter square. So here you have to understand they given centimeter. So they given centimeter. We should convert into meters. Keep in mind, always unit must be in one system. Units cannot be taken in different systems. So unit always be in one system, so that you can make it SI system. So I'm considering area of the cross section. Now you can go for R also given, resistance 10 ohm. So 10 ohm is given. Now you can find out the length we have to find out. So normal formula is R equal to rho into L by A. So rho into L by A. So this is the formula. R equal to rho into L by A. So R equal to rho into L by A. This is the formula. So if you are doing this problem, so while doing problem, check once whether all units are there in one system or not. You can check. Later you substitute the values in the formula. All the values in the formula. So now I am substituting here. You can see here. So here we must convert into SI system, right? So 1 meter equal to 100 centimeter. So 1 centimeter equal to 10 power minus 3 meter. 10 power minus 2, right? So we'll get 10 power minus 2. 10 power minus 2 meter. Okay. So now they are asking centimeter square. Centimeter square means 10 power minus 4 meter square. So now you can substitute. So R equal to how much? 10. Rho equal to how much? Rho equal to 1.6 into 10 power minus 8. 1.6 into 10 power minus 8. And so length we have to find out by area of the cross section is 20 into 10 power. So here minus 4 and here minus 4. You'll get 10 power minus 8. Correct? 10 power minus 8. Minus 4, 10 power 8. So a power m into a power n. So a power m plus n. So according to that formula we can take. Now I am considering if your cross multiply. Anyway, this will get cancelled. So cross multiply L equal to 20 into 10 by, so 1.6. So how much will get length? How much will get? Can you tell me? How much will get length? Anybody? So check once and let me know the answer. Check once and let me know the answer. Give some. Take some time. Take some time. Take some time and let me know the answer. How much is the answer? Anybody? So I hope I don't know, sir. 125. 125 meters, centimeters, meters. We convert into meters, and L equal to 125 meters. So that is the answer. That is the answer. So now you can see. Clear? So first once again. So once again, how to take? First you have to consider. So first you have to consider area resistivity is given. Area of the cross section is given, resistance is given, length we have to find out. So formula R equal to rho into L by A, R equal to rho into L by A, we can take the formula. So here R into, so rho into L, L equal to, so we are taking this one, L equal to 125, I'll get it, 125, I'll get it. Is it clear? Any doubts? Do you have any doubts? So let me know if you have any doubts. So otherwise we can go to the next one. Extraordinary question. So this question I hope already explained this one. So this question came in the previous board exam. Very, very important question. So even I like this question. Okay. So because sometimes we'll get confused while doing this question. Very simple question, very easy question, but still we'll get confusion. So I'll tell you how to do it. So basic formula, still we'll use basic formula. So electric current formula only. So I equal to Q by T. I equal to V equal to IR. Ohm's law formula we will use. V equal to IR. V equal to IR. Ohm's law. Ohm's law formula we are doing. Ohm's law formula. Come on, everybody. Come on, be ready with our pen and book. So try solve with me. So question given I equal to 500 milliampere is given current and containing an electrical lamp. So resistance of lamp and resistance of the conductor. So RC. Find the resistance of the electrical lamp. So electrical conductor, so R, and when connected to V equal to 6 volts. Find the resistance of the lamp. We have to find out the resistance of the lamp. Very important. 2 marks question. 3 marks question, not 2 marks. So this question is 2 marks only. This question is for 2 marks question. Very important. Very important. Very important. Very important. Definitely this question will come for exam. This models, at least this type of models related to Ohm's law, question will come. So now shall we do it? Anybody know the answer? So anyone who is participating? So myself, Siva sir, I'm only participating, so I'm doing. So here we can say V equal to IR. Sir, we will use this formula. Very simple only, no, sir. Yes, that's why I'm telling. But here they given in milliampere. So I equal to 500 into 10 power minus 3 ampere. So 1 milliampere equal to 10 power minus 3 ampere. 10 power minus 3 ampere. So keep this one in mind. So now we can see V equal to 6 volts. I equal to 500 into 10 power minus 3. RC plus RL, resistance, right? In the place of resistance, 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 we can substitute RL. So 6C equal to 500, 500, 500, 500 by, so RC equal to 10 plus RL. So now you can see if you are taking 6 by 500 into 10 power minus 3 equal to 10 plus RL, 10 power 10 plus RL. So if it is goes up 600 into 10 power 3 by 500, so equal to 10 plus RL, 10 plus RL. So 6,000 by 500. So 20 got cancelled, 12. So 10 plus RL, 10 plus RL. So now RL equal to 12 minus 10. So RL equal to 2 ohm. Because they are asking to find out resistance of the lamp, So like that we can do the problem. Like this we can do the problem. Do you have any doubt? Check once. So current is given, resistance of the conductor is given, resistance of lab we have to find out, potential difference is given. So V equal to IR, 6 equal to current 500 into 10 power minus 3 RC plus RL. So now we can see RL equal to 2 ohm. So this is the answer, this is the answer, this is the answer. Very most important question. Keep in mind. So this question is very important. Very important. This type of questions only they will ask in the exam. Right? So next one. Next one. Name a device that helps to maintain potential difference. So which device is used to measure, maintain the potential difference? Device, maintain the potential difference. Measuring voltmeter. So maintain is battery. Okay. So actually there are so many questions are there. Number of questions are there. So still we'll do it. Okay. So we'll do it. Definitely tomorrow also you can join to the class. So we'll see for okay. So too many we can go with that. So I'll sing one song for you. I'll teach how to sing also. I'll teach these songs. Myopia song. It's completely related to subject centered song. So finally to learn in easy way. Okay, to learn in easy way, to know in a easy manner, to remember in easy way. So I created all these songs for students' sake. Only I'm saying I create all these songs. Like there are 10 songs are there. So this is related to myopia. Okay. Myopia. Near distance we can see, far distance we can see. Myopia. For the correction we are using. Bro, what bro? For that correction we are using concave lens, concave lens, concave lens, concave lens, concave lens. So that's enough. That is the myopia song. So one more song is there related to sign conventions, light reflection and diffraction. And the not only this song, so like that hypermetropy also there. So new Cartesian song I'll sing. So that is completely related to light reflection and diffraction. New Cartesian sign convention, new Cartesian sign convention, all the distance measure from the pole. Distance positive along the instant race. Distance negative opposite to instant race. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. So that's enough. That is about new Cartesian sign conventions related to sign convention. So to all these, whatever experiments, whatever the work I'm doing related to physics, so it will be helpful for students. Okay, it will be helpful for students to learn, to remember. Okay, so normally what we know, so songs we can learn, we can remember whenever we want, we can sing. Okay, normally if you are going out, if you are being, so normally subject we may not discuss, but song we can sing, right? Song we can sing if you know the content in the form of sing. So whenever you, myopia, 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 near distance we can see, far distance we can see, myopia, myopia, myopia. For that correction we are using concave lens, concave lens, concave lens, concave lens. So like this, so subject we can sing. Subject we can sing. विवेक क्लिप काट के इंस्टा पर लगने पड़ेगी. I know little, so can you clip काट के what is that means? Can you type in English if it is possible, because thoda thoda Hindi aata. Okay, fine. So like that. So like that is created songs, and hypermetropia also there. Hypermetropia. It's a so I'll sing one more song for you only. Remember my name, Siva sir. So my channel name is Student the Brand. Hypermetropia, 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 hypermetropia. Far a distance we can see, in near distance we can see. Hypermetropia, hypermetropia. hypermetropia, hypermetropia, hypermetropia. For that correction, we are using convex lenser, convex lenser, convex lenser, convex lenser. So that's enough. So like that. So many, not only one, like that. Many I did. So still I'm going to do experimenting in physics. See, the people who are doing experiments, okay, so whether it is useful in that particular generation or not, so in the definitely will be useful for the future generations. So my work completely dedicating to physics. Uh, uh, no, to teach the physics in the best way, best possible way. So I'm teaching. So like all songs, all experiments. You can see my YouTube channel also. You can see the YouTube channel. There are many videos related to experimenting. Experimental activities are there. Experimental activities are there. So that is point. So if you like this video, please do like, share, and subscribe my channel. So this is the Student the Brand channel. So myself, I am Shibashar. So that is a Student the Brand channel. So I'm teaching physics. So CBSE Grade-10 physics. So those who are there in class 10 CBSE, okay, so you can come and join to the class and inform and drop a one board. So regarding Student the Brand. So we'll see in the next class. We'll discuss more points. We'll work out for board exam with a sincere, serious, and with the target mode. Okay. So definitely, if you join to the class, it will be worthy. It will be worthy. So you can learn the concepts in easy way. Okay. So that's enough. So this is Siva sir. This is the Student the Brand. Welcome to the channel for learning physics. Thank you so much. Signing off. Namaste.